Your arteries are deciding your future right now, silently responding to every nutrient, every stress signal, and every biochemical message flowing through your blood. Long before disease ever gives you a warning sign, imagine your arteries not as rigid pipes, but as living, intelligent tissues that respond continuously to your inner environment. They sense pressure, chemistry, emotion, and time. Every heartbeat sends not just blood, but information, brushing against the arterial wall and asking a quiet question: are the conditions safe, calm, and nourishing, or hostile and inflamed? Long before disease earns a name, these vessels adapt. They tighten slightly in response to stress hormones, stiffen when inflammation lingers, and lose flexibility when the biochemical signals of repair are drowned out by noise. This process is gradual, almost polite, which is why it so often escapes attention. Modern science has begun to confirm what physiology has always hinted at: arteries are not passive victims of aging, but dynamic participants in health. The inner lining, known as the endothelium, behaves almost like an organ of perception. It releases substances that tell vessels when to widen, when to narrow, when to invite immune cells, and when to send them away. When this lining is nourished, blood flows with less resistance, pressure normalizes, and oxygen reaches tissues with ease. When it is irritated or starved of key nutrients, the arteries respond defensively, becoming less flexible, more reactive, and gradually less open. This is where nutrition shifts from the idea of fuel to the reality of communication. Vitamins are not simply ingredients filling a deficiency chart. They act as molecular messengers. They bind to receptors, influence gene expression, and alter how cells interpret their environment. In the arterial wall, this means shaping inflammation, oxidative stress, mineral balance, and cellular repair. A lack of these signals does not cause sudden collapse, but it nudges biology toward survival mode, where protection replaces openness and stiffness replaces flow. The phrase unclogging arteries often evokes mechanical imagery, as though plaque were a drain blockage waiting to be dissolved. But biology rarely works through force. Plaque forms as a response, not an accident. It is the body's attempt to stabilize injury, inflammation, and oxidative damage over time. Understanding this reframes the question. Instead of asking how to remove plaque, science increasingly asks how to remove the conditions that made plaque necessary. When those conditions soften, the body begins to remodel itself, quietly and patiently. This perspective invites compassion rather than fear. Arteries do not fail overnight, and they do not heal overnight either. They listen constantly to what circulates within them: nutrients, hormones, inflammatory molecules, and signals of repair. When vitamins are present in adequate and balanced amounts, they whisper instructions of calm, flexibility, and restoration. Blood vessels respond not with dramatic change, but with subtle improvements in tone, responsiveness, and resilience, unfolding over weeks and months as the body remembers how to maintain open pathways on its own. Vitamin D enters the conversation quietly, often misunderstood as a nutrient concerned only with bones, yet its deeper role unfolds within the arteries themselves. At a cellular level, vitamin D behaves less like a vitamin and more like a hormone, influencing how cells listen, respond, and adapt. Receptors for vitamin D are embedded throughout the cardiovascular system, including the endothelial cells that line every artery. This alone tells us something important: the body did not place these receptors there by accident. It suggests that vitamin D participates in the daily decision-making process that governs vascular tone, inflammation, and long-term structural integrity inside the arterial wall. Immune cells constantly patrol, responding to signals of damage or stress. When vitamin D is sufficient, these immune cells tend to act with restraint, producing fewer inflammatory messengers and more signals associated with repair. In deficiency, the balance shifts. Inflammation becomes louder, more persistent, and less discriminating. Over time, this low-grade inflammatory state encourages stiffness and dysfunction in the arterial wall, not through dramatic injury, but through chronic irritation that slowly alters how vessels behave. Vitamin D also influences how smooth muscle cells within the artery respond to pressure and chemical cues. Healthy arteries expand and contract with each heartbeat, absorbing force and maintaining steady blood flow. This flexibility depends on precise molecular signaling. Vitamin D supports this signaling, helping arteries relax when needed and preventing excessive constriction. Without it, vessels may become more reactive, responding strongly to stress hormones and contributing to elevated blood pressure, which further strains the vascular system in a self-reinforcing cycle. Another subtle role of vitamin D lies in its relationship with calcium. Calcium is essential for life, but its placement matters. When regulatory systems falter, calcium may deposit in arterial walls, contributing to calcification and loss of elasticity. Vitamin D, when balanced with other nutrients, helps regulate calcium metabolism in a controlled manner. It does not indiscriminately push calcium into tissues. Rather, it participates in a coordinated system that determines where calcium strengthens and where it must stay out of the way. In this sense, vitamin D is less a builder and more a coordinator, ensuring that structural materials arrive at appropriate destinations. Perhaps most striking is how vitamin D links the external environment to internal biology. It is synthesized in response to sunlight, translating seasonal and environmental cues into physiological signals. This connection hints at a deeper biological rhythm, where vascular health is influenced not only by diet, but by light, movement, and time spent outdoors. Deficiency, then, is not merely a missing nutrient, but a signal that the body has lost contact with one of its regulatory inputs. Through these mechanisms, vitamin D does not aggressively clear arteries. Instead, it supports the conditions under which arteries maintain openness, flexibility, and responsiveness. Its influence is gradual, systemic, and deeply integrated into how the vascular system remembers how to function as living tissue rather than rigid infrastructure. Vitamin K2 operates in the body with a kind of quiet precision that often escapes attention, yet its influence on arterial health is profound. To understand its role, it helps to think of calcium not as inherently good or bad, but as powerful. Calcium gives bones their strength and structure, but when it drifts into soft tissues, it becomes disruptive. The body relies on regulatory systems to ensure calcium is placed where it serves life, rather than undermines it. Vitamin K2 is one of the key directors in this process, activating proteins that guide calcium with remarkable specificity. Within the arterial wall, there are proteins designed to prevent mineral buildup, essentially acting as guardians against inappropriate calcification. These proteins remain inactive without vitamin K2. When K2 is present, they become functional, binding calcium and preventing it from embedding itself into the vessel wall. Over time, this guidance helps preserve the elasticity of arteries, allowing them to remain flexible rather than slowly hardening under the weight of misplaced minerals. The process is subtle and cumulative, unfolding quietly over years rather than days. This role reframes how we think about arterial plaque. Calcification is not random debris. It is the end stage of long-standing imbalance. Vitamin K2 does not scrape plaque away. Instead, it addresses one of the underlying mechanisms that allows plaque to become rigid and persistent. By supporting proper mineral traffic, it encourages a state in which arteries are less likely to convert temporary injury into permanent structural change. In biological terms, it supports adaptability rather than fixation. There is also an elegance in how vitamin K2 balances cooperation within the body. It works alongside other nutrients, particularly those involved in calcium absorption and bone metabolism. When these systems are aligned, calcium strengthens the skeleton while arteries remain supple. When alignment is lost, competition arises, and tissues begin to suffer unintended consequences. Keto helps restore that alignment, not through dominance, but through coordination, ensuring that systems meant to support one another do not quietly undermine each other over time. Beyond minerals, vitamin K2 appears to influence cellular behavior within blood vessels. Emerging research suggests it may play a role in regulating inflammation and oxidative stress within the arterial wall. These processes are central to plaque formation and progression. By supporting a calmer cellular environment, Keto contributes to the preservation of healthy vessel structure, reinforcing the idea that arterial health depends as much on internal harmony as on external inputs. What makes vitamin K2 especially compelling is how little attention it receives compared to more prominent nutrients, despite its strategic importance. Its effects are not dramatic or immediately felt, which may be precisely why they are so valuable. It supports long-term structural integrity, the kind that is only noticed when it begins to fail. By quietly maintaining order in mineral metabolism and vascular tissue, vitamin K2 helps arteries remain open, resilient, and capable of adapting to the demands of a long life. Guided not by force, but by biological intelligence, vitamin C moves through the body as both a builder and a guardian, shaping the physical structure of arteries while defending them from the quiet erosion of oxidative stress. At the foundation of every healthy blood vessel lies collagen, a flexible protein scaffold that gives arteries strength without rigidity. Vitamin C is essential for collagen synthesis, not as a passive ingredient, but as an activator that allows collagen fibers to form correctly and maintain their integrity. When this process is supported, arterial walls remain resilient, able to stretch with each heartbeat and return to shape without damage. Beyond structure, vitamin C plays a critical role in preserving communication within the vascular system. One of the most important molecules in arterial health is nitric oxide, a signaling compound that instructs blood vessels to relax and widen. This widening is not cosmetic. It determines how easily blood flows, how much pressure is exerted on vessel walls, and how efficiently oxygen reaches tissues. Nitric oxide is fragile, easily destroyed by oxidative stress. Vitamin C helps stabilize it, extending its lifespan long enough to do its work. In this way, vitamin C supports flow not by force, but by protecting the messages that allow arteries to cooperate with circulation. Oxidative stress can be thought of as biological noise, a byproduct of metabolism, pollution, poor diet, and chronic stress. When unchecked, it damages lipids, proteins, and DNA within the arterial wall. This damage triggers inflammation, which invites immune cells and accelerates plaque formation. Vitamin C acts as a buffer against this process, neutralizing reactive molecules before they can inflict harm. Its antioxidant role is not about eliminating oxidation entirely, which would be impossible and undesirable, but about maintaining balance so repair can keep pace with wear. There is also a deeper elegance in how vitamin C interacts with the immune system inside blood vessels. Immune cells rely on vitamin C to regulate their responses, influencing whether they escalate inflammation or assist in healing. When vitamin C is adequate, these cells tend to act with greater precision, reducing collateral damage to the arterial lining. This restraint matters because chronic, low-level inflammation is one of the primary forces that gradually transforms flexible arteries into stiff, narrowed pathways. Vitamin C's water-soluble nature allows it to circulate freely in the bloodstream, positioning it exactly where vascular stress occurs. Unlike nutrients stored away for later use, vitamin C must be replenished regularly, reflecting the ongoing need for protection and maintenance. This requirement mirrors the reality of arterial health itself, which depends not on occasional intervention, but on consistent support. Through these intertwined roles, vitamin C does not dismantle plaque or cleanse arteries in any dramatic sense. Instead, it reinforces the conditions that allow arteries to repair themselves, maintain elasticity, and respond intelligently to blood flow. Its contribution is steady, structural, and protective, working quietly in the background as arteries continue their lifelong task of carrying blood with grace and resilience. The B vitamins enter arterial health through pathways that are less visible but deeply influential, working within the chemistry of the blood itself rather than the structure of the vessel alone. Among these, vitamins B6, B9, and B12 play a central role in regulating homocysteine, an amino acid produced during normal metabolism. In small amounts, homocysteine is harmless, but when it accumulates, it becomes an irritant to the arterial lining. It disrupts endothelial function, promotes oxidative stress, and subtly encourages inflammation, creating conditions that make arteries more vulnerable over time. What makes homocysteine particularly concerning is its silence. Elevated levels rarely cause symptoms, yet they exert constant pressure on the vascular system. The B vitamins act as metabolic guides, helping convert homocysteine into other compounds the body can use or safely eliminate. This transformation reduces friction within the bloodstream, allowing the endothelium to maintain a smoother, more responsive surface. Rather than attacking plaque directly, these vitamins remove a biochemical stressor that encourages plaque to form in the first place. Vitamin E contributes to this environment by protecting fats within the blood from oxidative damage. Cholesterol itself is not inherently harmful, but when it becomes oxidized, it turns inflammatory and more likely to embed within arterial walls. Vitamin E, as a fat-soluble antioxidant, positions itself within lipid particles and cell membranes, shielding them from oxidative injury. By doing so, it reduces one of the key triggers that transforms ordinary lipids into drivers of vascular inflammation. Vitamin A, often associated with vision and immunity, also participates in maintaining the integrity of arterial tissue. It influences how cells grow, differentiate, and repair themselves, including those lining blood vessels. Adequate vitamin A supports a healthy turnover of endothelial cells, ensuring that damaged cells are replaced efficiently and that the arterial lining remains intact. This ongoing renewal is essential because even minor defects in the endothelium can become focal points for inflammation and plaque development. Together, these vitamins operate not as isolated agents, but as contributors to a broader biochemical harmony. They influence gene expression, immune behavior, lipid stability, and cellular repair, shaping the internal environment in which arteries function. Their effects are cumulative and interdependent, reflecting the reality that vascular health emerges from balance rather than singular intervention. This perspective challenges the idea of unclogging as a dramatic event. The body does not reopen arteries through sudden cleansing, but through sustained correction of the signals that govern inflammation, oxidation, and repair. When these vitamins are present in adequate amounts, they help restore a state in which arterial walls are less irritated. Blood chemistry is less hostile, and healing mechanisms can operate without constant interruption. In that state, arteries gradually regain flexibility and function, guided by a quieter, more orderly internal conversation that supports circulation as a natural expression of health rather than assist. Under siege.